Who here knows what biomimicry is? Such a stacked crowd in Cambridge. This does not usually get that response. Before I was executive director for both Cradle to Cradle. Do you guys know what Cradle to Cradle is too? Yeah. So innovation inspired by nature, and also how to look at products down to the parts per million. But before I was in that, I worked in the private sector, but I left because I felt like business didn't have a compass for how to move forward in a way that was going to ultimately be in harmony with nature. And so this talk today is really about a glimpse of how biomimicry is that directional compass for leading to a world that's safe for all living creatures. And the key is really to see it as being in a mutualism, is to see that we are in partnership and we can learn from nature and not just be in an extractive relationship. This is my home out in the redwoods. How beautiful is that? I believe that actually our future cities will function as perfectly as a forest. I've seen evidence that that's going to be the case. This is usually where people say, oh, she's from California, she thinks these things. But I firmly believe that if we approach the function-driven lens of innovation, this is where we're going to get to. Everything's going to feel that good. We have to remember, and everybody knows this, right, that we live in an entropy-based world where we move huge amounts of things. And this is the Sahara Desert, where 7,000-year-old diatomaceous dust is brought up every year. And diatomaceous dust is from the ancient little microorganisms that used to live in Lake Megachad. And it's brought up, and it travels enormous distances across the Atlantic in order just to fertilize the Amazon. Without that dust, the Amazon doesn't exist. And we move toxic things too. We just move things regardless. 58% of the ocean plastic is actually from paint. And nobody wants a world without paint. So the question is really, do we want to actually get rid of things, or do we want to remake things? Entropy is agnostic. We can move toxins, or we can move nutrients. It's really up to us. This is just a dark stat. We are moving toxins. And so we are at this place right now where I can't say that it's causation, but it's certainly correlation. The numbers are just pretty staggering. I have a personal experience with cancer, with my parents both dying. I have friends who have died. There's probably everybody in this room knows somebody who's died from cancer. This is the new thing that we have to wrestle, and our stuff is probably a huge part of it. Take perfluorinated chemistries. It's in everything. It's from our rain jackets to our Teflon pans, and it's causing huge amounts of issues. So we can think about either replacing PFCs, which is starting to be regulated, with either maybe some regrettable substitution. Maybe we can engineer for every potential route of exposure that they could ever leave, right? We could filter water better, or we could, take care of our cleaning up process better, or we can design differently from the beginning. These handsome guys are springtails. And the way that they work is they have those little tiny hairs, but they also have these nano bumps. And those nano bumps are shaped like mushrooms. And what's amazing about the springtail is the water because the surface tension of water can hold together, the bumps essentially just support it. So he just shakes off, the water drops off. The springtail is also one of the few organisms in nature that can repel oils. It's a little fun fact for you. And it's being inspired to create better products. So we don't have to use PFCs. There's a company called Amphico, which has created Amphitex. They have actually taken the structure of the springtail and woven it into their fibers. No hazardous chemistries are needed at all. It's a single monomaterial that is able to be recycled when they're done with it. The number of papers and patents in biomimicry is going through the roof. This is actually an old stat. This is 7 years ago. It's only grown since then. So what I want to talk about are the ways that biomimicry is supporting business to invent better products that will serve a healthier world. Because again, what we're aiming for is a mutualism. We get better ideas from nature, and in return, we protect nature. Good for both sides. So number one, nature offers a library of time-tested ideas that work. That means that we can invent faster. Humans, we get things wrong the first 17 times we try them. Nature, if we're starting with a design that's already worked in nature, we have a leg up. In terms of a technology readiness level, that's a big advantage. So we know how to build with trees, but do we know how to build the way that a tree builds, right? We could either look at how we can use more structural supports and bigger beams, or we can do what this company, Strong by Form, which is a Chilean company, did, which is they looked at the ways in which a tree manages for stress and for load. It's an amazing thing, right? They're very lightweight, but a tree has to support long, long limbs, especially in frost or wet environments. So what they did is they created a product called WoodFlow. And WoodFlow uses wood flakes that they compress, and they use a tiny little bit amount of resin, and it's done through additive manufacturing. And those ridges that you see is where they lay down more lines. And so they're optimizing for load based upon based upon the structure that they're trying to create. And by using wood flakes instead of timber, they can use the entire tree, almost, except for the leaves. And that means that they could also use different species of trees, which is a huge advantage. So when it comes to actually harvesting, they can harvest far less. Again, that's an example of a mutualism. We don't have to cut down as many trees if we can use a greater percentage of them and design in different optimized ways. By the way, WoodFlow is as strong as concrete or steel in built environment situations. This is point number 2. Nature designs improve the system around it. Or as founder of biomimicry, Janine Benyus says, life creates the conditions conducive to life, which is really like a great prime directive for industry when you think about it. If you're not making something that enhances life on the product, then you're making something that might be making it worse. It's really that simple. For example, we have very little access to fresh water on this planet. About what, 1% is the common understanding. And yet we contaminate most of that, as we were just talking about with paints being 58% of ocean plastic, which all of this is kind of like shocking until you think about where do you wash your paintbrush? Or if you've ever tie-dyed. If you've ever tie-dyed anything before, you know how much synthetic dye is being washed out. We make about 70 million tons of synthetic dye every year. It takes a lot of water to move that through. And in the world of biomimicry, structural color is always the answer. The way that feathers and butterflies work is actually through structural forms that either cancel out parts of the visible spectrum of light and then bounce only that portion back to your eye. So it's permanent color. There's no pigments or dyes. It's never going to fade. Biomimicry always talks about structural color, and it's been around for actually decades as a concept, but most of the innovations out there have actually used plastic. And this company, Sparxel, is using cellulose, which is a big-time game changer. It's a UK-based company, and they're moving from this sort of disordered format of cellulose to ordered format so they can actually emulate those different structures to cancel out and reflect the colors that they want. This is like, look at how beautiful this is. They actually also make pigments, so in addition to a world that's safe for glitter, we now will have safer pigments, and that's again back to being sort of in a mutualism. When these things escape into the world, as they inevitably will, let's like not pretend that physics doesn't exist, right? When these things escape, we want them to be safe. So if they're cellulosic, if they're plant-based, we have a much greater chance of that safety. I think everybody should know about biomimicry and that it exists, but the people I really want to know about it are young people, because they're entering a world that's, let's just face it, like urgency is going to be the #1 issue. They need to know that their ideas are going to work. So the way that we've actually been helping students get educated is through a youth design challenge. Biomimicry is taught in hardly any K-12 schools in the United States. Actually, worldwide, that's pretty much true, except for Germany. So what we did through these design challenges, they have to pick a local sustainability issue. They find the plants or animals or insects that actually solve for that, like how does nature capture water or filter, et cetera, and then they build their designs. So let me tell you about a couple of them. The first one's kind of amazing because they actually, this is a middle school team of two 14-year-old girls who had an insight which not very many people in the industry have had, which is that for wind turbines, they don't do very well with either minimal wind or with turbulent wind, and yet dragonflies do. Maple seed pods do. And what they found was, there's this quote, the biggest thing we discovered was how efficient a flexible blade would be. We found this in almost all of our biological models. And there aren't a lot of flexible wings in industry, whether that's wind turbines or planes, except that Airbus recently announced Albatross One, which actually does have extraordinarily long, flexible wings that flap in turbulent wind, which cuts down on drag, reduces fuel consumption, and therefore emissions. I just think it's amazing that 14-year-old girls in aerospace engineers finally had the same realization. This is a team out of Seoul, South Korea. In South Korea, there's a huge problem with styrofoam buoys. There's 41 million oyster farms that are going on all the time, and they all use styrofoam buoys, and it's littered much of the bay. These kids wanted to address that, as did the Korean Ministry of Oceans and Fisheries, but they had already introduced a new buoy, which had also failed. And so these kids, high school kids, decide, like, we're gonna solve it. We're gonna use a design that we know works based upon how nature does it. This is the Hydrochaeris dubia plant, which has an air pocket and a large flotation leaf on the top. And they emulated it really perfectly. They found it by making it out of chitosan, which is a mixture of like shrimp shells and beetle shells, so it's easily broken down in the environment when that time has come. They were able to be successful. They knew that there wasn't going to be a lot of patience for iterating over and over again. And so they went with an idea that worked. And I think about this in the perspective of the climate crisis that we have right now with our kids, right? 66% of kids internationally, this is a Lancet report, said that they're sad. They're just sad about the future. That number is also equally high when it comes to anxiety. But when we did a survey of the kids that participated in the design challenges, a couple things happened. Number one, they felt connected to nature like they never had before. That was a direct quote, actually. The teacher said that their creativity went up, their critical thinking went up, their connection to understanding science went up. But I think the most amazing statistic out of all of it, and it gets me every time, is 92% of them said that they felt for the first time like they could come up with a solution that mattered. They could make a difference. So I think that biomimicry, not to oversell or anything, but it could be the antidote to climate anxiety. Which leads me to my last point, which is that working in concert with nature is going to be the new jobs economy. And it's here, but it's not evenly distributed yet, as they say. Most of the biomimicry labs are concentrated in the global north, wealthy academic labs, mostly in particular. But the issue is that a lot of those academic labs, not only are they in the north, but they're also not talking about how they're going to give back to nature. But recently I met Kenyan national treasure and friend, Paula Kahambu, and we were talking about how biomimicry really could be the answer to lifting the next generation of Africans out of poverty. She instantly saw it as the lens that was missing for her conservation work. She works with over 200 schools. So now what we're going to do is partner Morpho Collective, which is the new organization, and then together we're going to start a new program called Wild Entrepreneurs, which is starting hopefully in next fall. And we're going to basically be able to bring together conservation, so people who know deeply about wildlife, together with the innovation lens of biomimicry and a pretty crazy prototyping makerspace, and watch what these kids can do. So I'll leave with this. We're entering into a new period of likely business deregulation, which could mean more extraction and more harm. But it doesn't have to, right? In a time when there's less accountability, creative solutions is the way out. We live in a planet of 8 or 9 million species. Each one of them has a vast library of functions that it performs and mechanisms to do it. That is the creative solutions that we need to access. It's all available for us. We just haven't known how to look. We haven't trained people how to look in that way. But that's just my head talking. I really think that the heart has to matter here as much. And the gift for me of biomimicry is the ability that we can have that same experience of what the kids have had, which is that we can connect to nature in new ways. And we can find a way to co-create an entirely new reality. Thank you.